Ready? Okay, great. Well, thank you, Chaz, for the introduction, and thank you everybody for joining. I'm sorry I'm not able to be there in person. Go ahead and share my screen. All right, is that working? Okay. So thank you for inviting me to speak and coming today. One of the things that we're going to talk about today is improving quality at solid waste facilities, MRFs and composting, and using a data-centric viewpoint. So taking data that's available at the facility, that's low cost, low effort, but can have a big impact on operations. So a little bit about MES. We're unique. We're an independent state agency, so we're not-for-profit business unit of the state of Maryland. We're non-regulatory and we're non-appropriated. So we provide all sorts of environmental services to state and local governments, federal governments, industry, and private sector. We have about 700 employees. We are active in every county across Maryland. We have over 1,000 projects in the region, everything from water, wastewater operations to dredging and environmental monitoring. And then my area, which is solid waste, composting, recycling, and landfills. Specifically for recycling operations, we operate 2 of the largest material recovery facilities on behalf of counties in Maryland. One is a single stream facility, one is a dual stream facility. We also operate a rural collection program on the eastern shore of Maryland for recyclables. We also operate organics composting facilities, some of the largest ones in the state, and one that's the largest in the East, one of the largest on the East Coast. So one is just yard trim, the other is a mix of yard trim and food scraps. And we've got about half of the capacity at that site is available for food scrap composting. And then we also operate a marketing department that sells all of the material recovery from the MRFs and also the compost into the general market throughout the region. So as with any collection program, contamination is a huge concern. Right? Anytime you're picking anything up from a curb, you're relying on people to make the right decision and putting the correct material in the correct spot to get it where you want it to be. And it's a continual challenge. Large-scale material recovery facilities that serve big regions often have a contamination rate of 20 to 30%. We heard that a little bit with the first speaker. So this is not specific to any of the facilities that we operate, but it's a general industry standard. So you're bringing in 20 to 30% of material that doesn't have a home in your bales. The Institute for Scrap Recycling Industries, that they build out standards. So if you're selling into the recycling market, that's really the kind of language that you'll use to talk about what material you have and what the standards are. The standards for those bales are in some cases as low as 0 to 5%, depending on the material contamination or output. So you've got to take that 20 to 30% contamination rate and get that down to 0 to 5% in order to have a reliable and strong market for your material. So each MRF is designed to build standard commodity bales that go to specific mills and meet their requirements. One of the questions we get a lot as MRF operators is, why can't I recycle this? This county says I can recycle this, this county says I can't. And a lot of that is dependent on the individual MRF, their equipment, and their end markets. Because that end market is going to pick that bale up and put it into their processing system, and they expect it to conform to those standards. So depending on what that MRF, what equipment, how many people, and what kind of processing that MRF has, it's going to vary a little bit as to what they can take. And then where they're selling to will define how much of things like coated paper can go into those different bales. Out of the tonnage that's coming into MRFs, you're really making just a few individual types of materials. Right? Paper bales, cardboard bales, aluminum, steel, plastics of various types, rigid plastics, and then glass bottles. And it's critical in the operations of a MRF to make sure that you're getting as much of your material into those bales as possible. So a steel can that ends up in an aluminum can, it's contamination. They don't want it. Aluminum cans that end up in paper, or plastic that ends up in paper, that's not going to be recycled. That's just contamination. So it's really important through the process of a MRF that you're making sure you're getting as much of this material into the right places as possible so that you can both get that recycled and receive revenue for that material. Generally, about 70% of the end product of a MRF is paper and cardboard. So that's really where we spend a lot of our time focused on contamination, because that's a huge volume. So individually, it's not the highest value commodity, but by volume, it's really the strongest source of revenue for MRFs. So what did we look at here? We looked at some data-driven decision-making. My background is in biology. I'm a scientist by training and kind of by mindset. So I like to have data when we're making decisions so we can look at what we're doing and we can really make decisions that reflect the reality and not our opinions. So collecting data from your operations creates a window and a snapshot into the process, and you can adjust on the fly. If you can develop some leading data, which is what we'll talk about as we move further through the presentation, you can adjust and you can make sure that you're making the best quality material on the front end without waiting until 6 months go by and you get a contamination document from your mill overseas. The goal is to properly staff these facilities and maintain quality control and continuous improvement. And some of these metrics have helped us do that. Specifically, the things that we're going to talk about through the rest of this presentation have helped us get almost a 47% decrease in our average fiber bale contamination at one of the facilities by making some of these changes and by really tracking our performance of our sorters and equipment. So everybody has your performance data, right? Your operational data, tons in, tons out per hour, runtime, scheduled, unscheduled downtime, cost and revenue. So that's pretty standard. That's not really what we're going to talk about for the rest of this discussion. What we really were trying to do is say, how can we see what's coming off of the line in real time? How can we get an idea of the quality of the material when we're making 6 or 7 loads of paper a day? How can we get an idea of whether or not that material is going to be decent quality and what we expect? And how can we measure our site's performance? So we've always used your kind of standard contamination measures. Waste sorts and audits, that's far leading data. That tells you what's coming into the facility on the front end. That's that 20 to 30% contamination rate on the tipping floor. But that's so far ahead of your process that it doesn't help a lot when you're trying to decide whether the material you're making on a day-to-day basis is meeting your quality standards for your customers. We've also always used bale breaks for commodities. So this is just an example of what our fiber bale break would look like. The latest there is the paper. The kind of middle blue is OCC, or old corrugated container cardboard, and then you've got this very small section that is actual trash along with some aluminum and steel. But that's lagging data. Once you do that bale break, you've already made all loads. Loads have been shipping. So that tells you a little bit about where you can improve, but it's not a current and quick turnaround time. You're not seeing in real time the kind of material that you're generating. So one of the things that we did, something we call line sorts. We have 3 fiber control lines at one of the facilities, or 3 fiber quality control lines. And we wanted to see what we could do if we took snapshots, basically, of the contamination coming off of those lines. So we collect samples 3 times a week. You can see here, these gentlemen have a tarp. The tarp has some handles. They lower that into the chute as the material is coming off the quality control line. They lower the tarp in, they take a 15-second sample. In that 15-second sample is then set aside, and we basically evaluate it the same way you would evaluate a bale break. We separate it, we weigh each type of material, and then that gives us a snapshot of what we're actually doing on that particular line. This is the example of a recent line sort that we've done. So we've got the 3 screens across, or 3 lines across the bottom. Each one originates from a slightly different location. The bright blue is the sample weight in pounds. The dark, like navy color, is the contamination in pounds. And that middle blue bar in the middle is the percent of contaminations. So you can see that the percent contamination for each one is, the highest one is roughly 1% in that particular snapshot. We've also learned a couple of other things about our line sorts from these, or our line sorters. This correlates really well with their performance. We're able to tie it back to the individuals. We're able to discuss it with their team on any given day. So if we see variation in the contamination, we're able to do retraining, or we're able to really focus on what our people are performing, what are they looking for, and how are they doing by doing this regular line sort that correlates directly instead of waiting until we do a bail break at the end. We've also seen some interesting patterns. So this is the average contamination by screen or by line. So we've got 3 quality control paper lines, and this was 100% of the contamination that we saw on this particular line sort. One line was roughly 50% of that contamination. And that makes sense given what we know about the outline of the facility and the way the facility is structured. But what this allows us to do is then target that line. We know that that line is going to have significantly more contamination. It's going to have to be pulled and cleaned. So we put our better people there. We make sure that our most senior people are there. We make sure that they understand and have training as to what they're looking for, so that we're better able to target that line and keep that material and keep the contamination down. We're also able to use this to look at upgrades and to start making recommendations about technology changes. And we know where to target, right? What we need to start first and what kind of resources we need to expand there. Anyone that's operated a MRF will tell you that screen cleaning is endless. It's constant and it just continues to go on and on all the time. Plastic bags are a continual issue for all recycling facilities. We've cleaned the screens at the facility several times a day. And previously, our employees would go in, they cut all that plastic out so that the material can sort properly and get where it needs to be. And they weren't doing anything with that information. So what we decided to do was start weighing what was coming in from those screens. So when they were cutting that material out, they're bagging it up, we started weighing the bags. And that again ties back directly to what's coming off of the line, what our sorters are performing, and what our sorter performance is. So what we found was it was a very low effort for some good data, right? We're doing it anyway, you just weight it. It informed our cleaning procedures. We were better able to streamline our procedures by getting some of the weight and time measurements. We also used it to train and manage our sorters and adjust staffing and provide feedback to our contractors. So through this process, we ended up seeing a standard decrease of over 200 pounds of material that has to be cut off that screen nightly. So what that means is that our sorters are doing a better job pulling that material off of the line. They're getting those bags, they're getting garden hoses and whatever else is going to end up in that screen before it gets to the screen. So by tying the weights of the screen to the performance of the sorters, using that for training and feedback, we've seen significant increases in the correct type of sorting to keep that material out of the screen. So not only does that save time and effort for our folks who have to clean the screens every night, it also ensures that the material that needs to be processed through that screen is getting where it needs to go. Paper is floating over, or the cans and the bottles are falling down, and everything is getting where it needs to be. We've also implemented what we call bale surveys. So general industry standards, 3 pieces of contamination indicate roughly 0.5% contamination through the bale. So one of the things that we saw over the years is that there's a lot of, it's hard to get people to take ownership when the feedback comes from months away. If you're sending paper overseas, you're not getting feedback on those for 3 to 6 months. So it's difficult to correlate that back to your baler operators, to your forklift operators, to your operators loading the trucks, people on the ground. By putting these surveys into place, we've allowed our individuals to take ownership of those bales. We've taught them how to look at those bales and how to identify bales that on the surface look too contaminated and need further evaluation and may need to be sent back through the process. So everyone has had this training. They look at the bales, they're able to understand what they're looking for and what levels of contamination would make a bale unacceptable and set aside for management review and then sorting and breaking that bale. So we've improved ownership and we've improved our quality through these things because we're better able to keep track of those bales, and everybody that touches it is looking at it with a critical eye to make sure the quality of the material is high enough to be sent to our end users. So operations wise, data-driven metrics, it really, really works for us. So it's very difficult to argue with data, right? When you've got a contractor, you've got contract labor, and you're showing individuals that here's the number on Monday and here's the number on Wednesday, what changed? That's very clear. It provides quick feedback. It provides evidence-based staff planning and training. We're better able to target our people. We're better able to put them in the right places to make a high quality. And when you combine this with on-site observation and management feedback, hand speed assessment, and other types of metrics, you really get a strong performance evaluation of your sorters and your operators. And it's a way to take that 20 to 30% contamination that's coming in the door and monitor it, really get your people to take some ownership of the product that they're producing and continue to keep the focus on high quality and keeping the contamination out of your end bales. It also provides a strong basis for upgrades and return on investment calculations because we know exactly how much material is coming off of those screens. If we're going to upgrade the screens at some point, we're going to be able to calculate how much time it's going to take our people, how much time will be saved, the rates of contamination, and help justify upgrades to the facilities. And one of the biggest things that we've seen, because again, this is focused on paper. We do these things for most of our products, but really the paper is the bulk of the market. Fiber markets are competitive. And these kind of procedures, bringing that contamination down by almost 50%, has allowed us to access very highly competitive and highly priced markets. Not only has the contamination itself been beneficial, having procedures like this that our marketing team are able to discuss with our mills have allowed us to really demonstrate that we have a commitment to quality. So our buyers are comfortable making large scale commitments and agreeing to purchase our paper at a high value because they understand that we have a commitment to quality and we can demonstrate that. And we will know on the front end if we've got issues rather than waiting until a bale break at the end of the month after we've sent the full load to the marketplace. So this has been really successful. We've gotten good feedback across the board. It's got low cost and low operational impacts. We haven't really bought much of equipment. We're not talking about using fancy AI. We're talking about using a tarp and a couple of minutes and a spring scale. We've found it has a lot of value for both operators, owners, and our buyers, and it's been easy to use and implement. These measurements have not taken a lot of time. They're not as labor intensive as, for example, a full bale break that takes a full day with 7 or 8 different people, but they give us that leading data that's going to show us what our quality looks like, how that material is going to come off, and how that's going to be accepted into the market. And that's pretty much it. There's my contact information. I'll hang around for any questions at the end.